What is the probability that 6 cards randomly chosen from a standard 52 card deck will all be of the same suit? We've done this type of problem before, but this time I want to concentrate on the fact that we actually have 4 mutually exclusive events here. The cards could all be clubs or hearts or spades or diamonds. And so because these are mutually exclusive, our probability that they're all of the same suit would be the same as the probability that they are all clubs plus the probability that they are all hearts plus the probability they are all spades plus the probability they are all diamonds. And each one of these probabilities would be the number of ways of choosing 6 cards out of 13, so 13C6, divided by the number of ways of choosing 6 cards out of the deck, which would be 52C6. And so the probability that they're the same suit is equal to 4 times 13C6 divided by 52C6. So we have 4 times 13 math prob combinations 6 divided by 52 math prob combinations 6, enter. So we get 3.37 times 10 to the negative 4th. So the answer is 3.37 times 10 to the negative 4th. We were asked to use scientific notation this time. Do remember that written as a decimal would be 0.000337. This time we're not asked to write it as a decimal, but realize that the probability of having all cards of one suit with a 6-card hand would be approximately 3/10,000ths. So now let's look at the next problem. And this is a little bit different of a problem because it says 4 horses are entered in a race. You randomly predict a particular order for the horses to complete the race. What is the probability that your prediction is correct? Well, how many ways are there to complete the race? This is now an ordering. And so it would be, there's 4 horses that could be first, 3 that could be second, 2 that could be third, and then automatically the last one would be fourth. This comes out to be 24 ways for the race to occur. Notice this is also 4p4, number of permutations of 4 things taken 4 at a time, or 4 factorial. So first of all, I used the fundamental counting principle. And in this case, you choose or chose one way So the probability that your prediction is correct would be 1 divided by 24. And here it asks us to report our answer correct to 7 decimal positions. So if we do on the calculator 1 divided by 24, we see that it is 0.0416 repeating. So 0.041667. It's a nice example of how permutations can be used in a probability problem. Our last problem in this set is another card problem where we are randomly choosing one card from a 52 card deck. And so what is the probability that it is a club? Well, 13 out of 52 of the cards are clubs, or 1/4 are clubs. What is the probability that it's either red or a club? These are mutually exclusive. So it would be the probability that a card is red plus the probability that it's a club. So we'd have 26 out of 52 plus 13 out of 52, which is 39 out of 52, or 3/4 would be. So 0.75, 75% probability that the card is either red or a club. And what is the probability that the card is either a face card or a 10 or a 4? So the probability that it's a face card plus the probability that it is a 10 plus the probability that it's a 4, again, mutually exclusive, we'd have 12 over 52 plus 4 out of 52 plus 4 out of 52, which gives us 20 out of 52, or 5 out of 13, which does seem to be the correct answer, because out of every suit, 5 cards are either a face card, a 10, or a 4.